Hey people, welcome back. Thank you so much for joining. And this session, we are going to learn about how to calculate the process capability for a continuous data which is normally distributed. So continuous data, remember in my session when I was explaining about the data type, I explained about what is the data, which is the continuous or discrete or attribute or numeric, non-numeric and all. So for the data type understanding, you can watch those videos. And now suppose I am generating a random data. So process capability, we all know when we talk about the short term, we represent by CP or CPK, or we represent if in case we are calculating for the long term, then we represent this by the PP and PPK. Formula I explained in calculating the basics of the process capability in my previous videos. Now, suppose I generate some random data. Maybe you are looking for a process, let's say time to office. How much time you take to reach office and data is, and suppose it's normally distributed. And you take approximately not less than 20 minutes, but not more than 30 minutes as well to reach office. You have collected your data for last couple of days. Suppose here is the data for last 30 days, let's say. Based on these 30 days of data, you are trying to find out that what is your process capability if your data is normally distributed. So first thing what we'll do, we have to check this data, either this data is normally distributed or not. So if I just select this, paste in Minitab, check the normality with the Anderson-Darling test, stack, basic statistics, and here is the normality test. Selecting the data, by default Anderson-Darling is selected here. Click on OK. So I found, unluckily, my data is not normally distributed because p-value is less than 0.05. This they check, my data is unluckily not normally distributed. Assume the data which we have generated is normally distributed. Assume, and then we calculate the capability of this. So CP will be calculating with the formula, which is USL minus LSL divided by 6 time of standard deviation. And CPK is the minimum value of CPKL and CPKU. So to calculate CPKU or CPKL, if you want to calculate CPKU, is the USL minus average value divided by 3 time of standard deviation. And CPKL is mean minus LSL divided by 3 time of standard deviation. So this standard deviation plays an important role. When I just explain you standard deviation, if you are using a range method to calculate standard deviation, that means you will be calculating for the short term. And short term means CP or CPK. In case standard deviation, we are using the deviation method, then you are calculating for the long term, and long term means PP and PPK. Formula remains same. You can this the CP can be your PP, CPK can be PPK, or CPKU can be a PPKU, or CPKL can be PPKL. Only difference, which standard deviation you are using. Are you using calculated from the range method, or are you using calculated from the deviation method? That's how it the differentiated will be. So short term, how to calculate the standard deviation with the range method I explained in my previous video. Now I'm going to help you to understand the calculation with the help of deviation method. How to calculate standard deviation? I explained in my previous video when I explaining about the standard deviation. So I'm calculating directly. Suppose time to office we have taken 20 to 30. So in this case, my lower specification limit is 20 minutes. Upper specification limit is 30 minutes. Now I need the average value and I need the standard deviation. So average value, I will put simple formula as an average and selecting this data. So my average time which I am taking is around 25.5 minutes, little higher on the average side because 20 and 30, 20 plus 30 is 50 divided by 2 is 25. So my data is skewed little bit on the upper side, which means positively skewed. And the standard deviation of this data, stdev.s formula I will be using, and the variability in my process is around 3.41 standard deviation. Now I have all my data ready. What I'll do, I calculate the PP value because long term, when I'm using the standard deviation by deviation method, it will be the long term calculation. So PP will be USL minus LSL. USL is 30 minus LSL is 20. Divide by 6 time of standard deviation. Standard deviation is 3.41. So 6 into 3.41. So my PP value is 0.48 as per this data. Now PPKU will be USL is 30 minus average value is 25.5 divided by 3 time of standard deviation, which is 3 into 3.41. So PPKU is 0.43. Same way, I will be calculating the PPKL. PPKL will be, you will take mean value 25.5 minus LSL 20 divide by 3 time of standard deviation, which is this. So my PPKL value is 0.54. This is the way we calculate the capability value. Capability value, now what is the meaning of that? So let's understand the meaning. So PPKU and PPKL, we can convert into a sigma level ZUSL and ZLSL, which is the simple formula is you just take the PPKU on the ZUSL multiply by 3, you will get the sigma value. And the similar way, PPKL you take and multiply by 3, you got the sigma value on the lower side of specification. Now, what does it mean? I have to convert this value into the yield. So if I look for the yield value, yield 1.32 sigma is equal to, if I use the formula norm as dist in Excel, select your sigma value, Z value. This means there is a 90.64% chance that data will not miss upper specification limit because this is the ZUSL we have calculated, which means there is a 91.32 is equal to 90.64% chance that data will not miss the upper specification. Similarly, 1.61 is 94.65% chance that data will not miss the lower specification. Now, I got how much data will fall within the specification mean. So how much will fall outside the specification is your defect. So defect is always 1 minus probability or yield. So on the upper side of a specification, there is a 9.36% chance that I will miss the upper specification limit. And on the lower side, there is a 5.35% chance. If this is your defect, and I convert this into the total defect, so total defect will be sum of the defect on the upper side and the lower side. So I have taken the sum here. 14.70 is my total defect. So what is my final yield without any defect? Final yield will be 100% minus total defect, 85.30. If 85.30 is your final yield, so what is your Z value, Z bench of the sigma level long term? Because here is standard deviation we use to calculate the long term. So this can be converted with the formula norm S inverse 85.30 is the sigma level will be 1.04. So we got the value, we got the R's PP value, PPKU, PPKL, ZUSL, ZLSL, yield defect 14.70. And the same, you can convert even this defect into the DPMO as well, which is this value. If you multiply it by 10 power raised to 6, so your DPMO will be 147,026. So all the values you have got now. The same thing with the specification 20 and 30. If I pick up this data, I will show you in Minitab that how to get the same value. So I'll just copy my data. I think data is already there. So I'll go to the stat, quality tool, capability analysis, and here I'm selecting normal. Select your data, subgroup size by default 1, lower specification 20, upper specification 30. Let it go as it is and click on OK. So now you got your capability analysis. If I see from this CP value 0.52, CPL 0.58, and CPU is 0.47. This is for the short term. What we have to see? We have to see the long term. So PP, what we have to look, because the standard deviation we use for the deviation method, which we use for the long term. So 0.49 is your PP, 0.54 is the PPL, and 0.44 is your PPU. I just copy this graph and show you here parallelly. So look at this graph. And compare your values, what we have here. So you will see that PP is 0.49, PPL is 0.44, and PPU is 0.44. Now you have the expected and the overall performance as well. So what we have, this is your overall capabilities, the long term. So if you look for the overall 53,456 as in DPMO, which is approximately what we have the defect value, which is 53. If you convert this into the million, this will be the same, or 93569,936 is the same value, percentage or the ppm. Total is 147026. What we got total 147026 here and 14.70. Now, if you want to see what we have calculated, the sigma values, the USL and ZLSL, and final sigma is 1.05. So we can see from the Minitab, just edit your graph, go to the option, and select here benchmark sigma or the percentage data, whichever you will. So I'm selecting benchmark, and now I will be comparing my benchmark sigma. So Z bench you can see here is 1.05, ZLSL 1.61, and ZUSL 1.32. If I want to compare these value with what we have calculated, so I will show you that ZUSL, ZLSL is 1.61, which you see here 1.61, ZUSL 1.32, 1.32 here, ZBench 1.05, and ZBench 1.05. So this is the way we calculate the capability. Capability we convert into the sigma level. Sigma can be converted into the yield. 100% minus yield is your defect. Defect, you take the sum of total defect, will be total defect. 100% minus total defect is your final yield, and final yield can be converted into the Z bench value. That's how we calculate. Thank you so much. And in the next session, I will be explaining you about how to calculate the process capability for the not normal data. Thank you, people.